Hello, I'm Ali Kosti. I'm here with the 6th session of the LS PLC training. In this lesson, we're going to get more familiar with the important functions of the LS PLC. Alright, the first function we're going to learn about today is the move function. In the previous lessons, we got more familiar with this function and mentioned that it moves the input into the output, and the data type of the input and output must be the same. Alright, the next functions are logic functions, which include AND, OR, XOR, XNOR, and NOT. Now, we want to get to know these functions separately in more detail. Okay, our first function is the AND function. So, in the AND function, we have two inputs. It says our inputs can be any bit type, meaning the data can be of a logical type, which could be, for example, 2 bits, or maybe 2 bytes, or even 2 words. So, for example, let's assume we're using 2 bits. For example, bit A and bit B, and we want to AND them together. We say that if both of our data are 0, the output will be 0. If one is 0 and the other is 1, the output is still 0, and if their places are switched, like the first is 1 and the second is 0, the output is still 0. Our output will be 1 only when both of our bits are actually what? Are 1. So, when we AND 2 bits together, the output is 1 only when both of our bits are what? Are 1. This is the AND function. For example, we can illustrate this with a simple example, like connecting 2 switches to a lamp using AND configuration. And as you can see in the picture, the lamp only turns on when both switches are closed. If both switches are open, or if one is closed and the other is open, the lamp stays off. The lamp turns on only when both switches are closed. Like in this situation, it's only in this situation that our lamp turns on. An example of an AND function in industry that we can mention. It's about presses, for instance. Usually, presses have a start 1 and a start 2, so that we put one hand on start 1 and the other on start 2. When we press both start buttons with our fingers, that's when the press starts working. If we press only one of these start buttons, the press won't work. This is usually done in industry for safety reasons, so that, for example, our hand doesn't accidentally get under the press. So, in this press, when both start 1 and start 2 are activated, the press starts working. If we want to write such a program in the PLC, we need to use the AND function. We use the AND function for start 1 and start 2 together and assign the output, for example, to one of the PLC outputs, so that whenever both of these starts are activated, that PLC output is activated and the press starts working. Okay, the next function is OR, which means that if we are 2 bits together, when does our output become 1? When at least one of these 2 bits is what? Is 1. If the first is 0 and the second is 1, the output will be 1. If the first is 1 and the second is 0, the output will be 1. And if both are 1, the output will still be 1. So, for the output to be 1, at least one of these 2 inputs must be 1. If both of our inputs are 0, our output will be 0. In industry, we can also use the OR function. Suppose we have a signal lamp and we want to turn it on using either start 1 or start 2. Whenever we press either of these start buttons, our signal lamp should turn on. So, we can OR these two start buttons together, meaning we use the OR function. We assign the output of the function to one of the outputs of our PLC, which is connected to our signal lamp. So in this case, if we press either of these start buttons, our signal lamp will turn on, or even if we press both at the same time, the signal lamp will still turn on. Our next function is XOR. If we assign 2 bits to the XOR function, we say that the output will be 1 only when exactly one of the input bits is 1. If both of our input bits are 0 or both are 1, our output will be 0. The output will be 1 only when exactly one of the input bits is 1. Well, in industry, we can use this. Even in lighting systems, this is used in buildings. Imagine, for example, as you can see in the picture, we have a staircase. Usually, in staircases, they put a single pole switch at the beginning of the stairs and one at the end, so that if either one of these 2 switches is on and the other is off, our light will turn on. If we set both switches to 1 at the same time, or set both to 0, our light will turn off. Our light is on when one of these 2 switches is set to 1 and the other is set to 0. These are commonly called changeover switches, which we can use in lighting systems. And if we need to write a program in the PLC for lighting control, we can use the XOR function. The next function is XNOR. It's the not state of XOR. It means our output becomes 1 when both of our input bits are either both 0 or both 1. In cases where only one of our bits is 1, our output will be 0. Well, we can also use this function a lot in industry. For example, we have sensor A and sensor B. When both sensors show us the same value, for instance, when both are off or both are on, the output gets activated for us. We can also use this function a lot in industry. The next function is NOT, meaning whatever value we give at the input, it gives us the NOT of that value at the output. This can also be of the n-bit type. That means it can be a bit, a byte, a word, a double word, or a long word. Any bit type data we enter here, it will give us the NOT of it at the output. For example, suppose we put a bit here and our input is 0. It will make the output 1 for us. Or if we set the input to 1, it will make the output 0 for us. We can also use this function in industry. One of the uses of this function in industry is for situations when the power in our industrial environment, for example, goes out. If the power in our industrial environment goes out, our UPS, for instance, will activate and turn on a fan that operates in emergency mode in the circuit for us. So we can use this function for such cases. When the power is connected, this fan stays off, but when the power goes out, it triggers it for us and can turn on the fan, which is very useful in industrial environments. Alright, the next functions are numerical calculation functions, and the first one is ADD. To add 2 numerical data values, we can use the ADD function. The next function is SUB, which we can use to subtract 2 numerical data values. Next is MUL, which we can use to multiply 2 numerical data values, and after that is DIV, which we can use to divide 2 numerical data values. Alright, our first function is the ADD function. We say that we can give it 2 data values of numeric type. It can add these 2 numbers together for us and put the result in the output. And an important point is that IN1, IN2, and out all need to be of the same type. For example, if we set IN1 and IN2 as integers, our output must also be of type integer. Well, here's an example from industry. If we have two motors and we want to see how many hours these two motors have worked in total, we can use the ADD function and sum up the time that both motors have operated together. The next function is the SUB type, which we can use to subtract two pieces of data. Here, we say that this one has 1, that one has 2. The data we use here must definitely be numeric. It subtracts the second data from the first and puts the result in the output. So, these three pieces of data must all be of the same type. Here's an example we can use from industry. For instance, we have a tank with a specific volume. Here, it shows us how much of the tank's volume has been used so far. If we use a SUB function, it will instantly subtract the amount used from this 5,000, and in the end, it can show us the remaining volume of the tank here. Alright, the next function is the multiplication function. We put two numerical values as IN1 and IN2. It multiplies these two values together and puts the result in the output. And the important point is that IN1, IN2, and out must all be of the same data type. Alright, here's an example we can use for this in industry. Suppose, for instance, we have a DC motor. We want to observe the instantaneous power of this DC motor. If we have the voltage and the current that this motor is consuming, by using a MUL function, it multiplies these two values together and can display the instantaneous power for us. Alright, the next function is division. The div function is for division, where we place two numeric data values here. It divides the first value by the second value. It outputs the result. Just one thing to keep in mind here is that our second value should never be 0. If this value becomes 0, or if we set it to 0 here, this function will actually throw an error and our function will stop working. An example we can give for this in the industry. Suppose we have a production line with a number of bottles placed on it, and we want to see how many bottles move along our conveyor belt in 1 minute. If we place a sensor and count the number of bottles in 1 hour, then divide that by 60, we'll know how many bottles pass through in 1 minute, and we can determine how many bottles have moved along our production line in a minute. The next functions that are widely used and that we can use in programming are comparison functions. GT means greater than. GE means greater than or equal to. LT means less than. LE means less than or equal to. Equal means equal, and not equal means not equal. Alright, now we want to get familiar with these functions one by one. If we utilize a greater than GT function, and then carefully place a specific numerical value into the very first input field, we will then proceed to meticulously compare this initial value with the subsequent second value that has been provided. It says if the first value is greater than the second value, it returns 1. Otherwise, it sets the output value to 0. So, in these comparison functions, the important thing to keep in mind is that our output is Boolean. Either the condition holds true or it doesn't. If it holds true, our output is 1. If it doesn't, our output is 0. Alright, the next function is GE, or greater than or equal to. We say if our first data is greater than or equal to our second data, the output will be 1. Otherwise, the output will be 0. The next one is LT, which means less than. If our first data is less than the second data, our output will be 1. Otherwise, the output will be 0. If the data in this function, this is the LE function, which means less than or equal to. If our first data is less than or equal to our second data, our output will be 1. Otherwise, our output will be 0, and this function is not equal. If these two inputs are not equal to each other, our output will be 1. But if they are equal, our output will be 0. Not equal means they should not be equal to each other. Okay, for comparator functions, we can consider an example. For instance, we can say that in an industrial environment, if we want the temperature to be between 10 and 40 degrees, the fan and heater should be off. If our temperature goes above 40 degrees, the fan should turn on, but if the temperature drops below 10 degrees, the heater should turn on. If the temperature is between 10 and 40 degrees, then neither the fan nor the heater should be on. So, using these comparator functions that we've just learned, we can easily write this program. Alright, I've entered the XG5000 software environment so we can write this program together. So, to write this program, first we go to the local variables section, and just like I explained in the previous lesson, we define the variables we need. The first variable I need, I'll name T, which is related to temperature. I choose its data type as integer, because the temperature is displayed to us as a number. So, I select it as a numeric data type, specifically integer. The next variable we need, I'll use for the heater output. I'll name it heater. Its data type should be Boolean, and I'll assign it an address. That means I'll assign one of the PLC outputs to the heater. For example, output QX 0.0.0. So, I'll assign PLC output 0 to the heater, and I'll define another variable called fan. Its data type should be Boolean, meaning it should be either 0 or 1, and I'll assign it another address. That means I'll assign another one of our outputs, for example, output QX 0.0.1, that is, PLC output 1, to the fan. Alright, now let's get into the programming environment itself and write the program together. So, as we said, the first thing we want to consider is, if the temperature drops below 10 degrees, the heater should turn on. Alright, in this section, which is related to functions and function blocks, I click on this part, and if I also click on the main page, a window will open for me where I can access the functions. Let me mention that if we press F10 on the laptop, this window will also open for us. Alright, if you remember, the less than function was the LT function, which stands for less than. I'll confirm this. So first of all, I need to enable this function. That means if the function isn't enabled for us, it won't work. One thing I should mention about all functions is that every function also has an enable output. If our function works correctly, the enable output will become 1. For example, here I can assign a variable of type bit. If our function works correctly, this enable output will become 1, and we'll know that our function has worked properly. So, this enable output is present in all the functions we've explained to you today, and in all of them, we can consider a bit variable here to check whether the function is working correctly. Alright, I'll set this one to temperature. I click on the check mark. Alright, we say if our temperature drops below 10 degrees. Here, enter the number 10. So, we say if our temperature goes below 10 degrees. As we said, the output should turn the heater on for us. Now, here I'm going to use a set coil. I click on this, place it here in this section, and select the heater here. This way, our function works so that if the temperature drops below 10 degrees, our output becomes 1 and this set coil is activated. We've assigned the address of the heater to this set coil. That means it turns the heater on for us. Alright, let me point out something about these set coils. Whenever we use a set coil, we also need to place its reset right after it. Because when we set it, it keeps the output at 1 all the time, and we need to be able to reset it afterward, that is, to set its value back to 0. So, set and reset coils always need to be included together in the program, and we'll add the reset later on to turn off the heater for us. Alright, so that wraps up the first part of our program, which was about the heater. Now, for the second part, if I press F10 or click on this section, this window will open up for us again, which is related to the functions. This time, I need to select the larger function, and as we mentioned, we definitely have to enable the function. Of course, in the newer versions of the XG5000 software, when we call the function onto the page, it automatically enables the function for us. In older versions of the software, like the version I'm using now, we have to enable it ourselves, so that's something you should keep in mind. Alright, now here we say that if the temperature, again, here I select the checkbox. If our temperature goes above 40 degrees. So here, I enter the number 40. We say, then, if the temperature goes above 40 degrees, our output becomes 1 and it should turn on the fan for us. Alright, here again, I use a set coil. I place it here and select the fan here. So it tells us that if the temperature goes above 40 degrees, this output becomes 1 and turns on the fan for us. Alright, so this covers the first and second parts of our program, which are for turning on the heater and turning on the fan. Now, in the next part, we said that if the temperature is between 10 and 40 degrees, both the fan and the heater should be turned off. Alright, to specify that the temperature is between 10 and 40 degrees, first we need to build these functions one by one together. So, we say that the temperature should be greater than or equal to 10 degrees. So here in the function section, I need to select F10 or click here to enter the functions section again. To say greater than or equal to, we need to use GE. I'll enable this. So, we say that if our temperature is greater than or equal to 10 degrees, it gives us an output. For example, I'll name this output Out1 and its data type should be Boolean. So, this becomes Out1. This is the first part of our condition. The second part of our condition was that the temperature should be less than or equal to 40 degrees. So again, I press F10, or we can enter the functions from this section. This time, I need to select LE, which means less than or equal to. I enable this function. So I say if the temperature, selecting T, is less than or equal to 40 degrees. I'll name the output out2, which also needs to be of Boolean type. Now, to say that the temperature is between 10 and 40 degrees, we need to and these two outputs, out1 and out2, together. That is, the temperature is between 10 and 40 degrees only when both of our conditions are met at the same time. And since we want both Boolean outputs to be true, we can and the two together. That means if even one of these conditions isn't met, our final output will be 0. So that's why we say both conditions need to be satisfied. So we have to and the two together. All right, here I'll press F10 again. This time, I'm going to use an and function. I'll enable my function and set output 1. And I'll and output 1 and output 2 together. Now from here, I'll take an output from my output. Now, with this output, I need to reset the fan, the heater, and my fan. So, I'll use a reset coil. I'll place it here. I'll assign one to the heater. And I'll put another one in parallel with it. Again, I'll place a reset coil, and this time I'll assign it to the fan output. So, we say that if the temperature is between 10 and 40 degrees, both the heater and the fan should be set to 0. That means the heater and the fan should be turned off. But if the temperature drops below 10 degrees, the heater should turn on. If the temperature goes above 40 degrees, the fan should turn on. If it's between 10 and 40 degrees, both the heater and the fan should be off. Thank you for your attention.